Hi there, what's going on? This is Chris, and today we are going to continue with the stat system. In this video, I'd like to add a few new features and also make some optimizations and fixes to our existing code. So right now, our percentage modifiers stack multiplicatively with each other, meaning if we add two modifiers that add 100% to our stat, we won't get 200%, we will get 400%. That's because the first modifier is going to double the value, going from 100 to 200%, and the second modifier will double it again, going from 200 to 400. But what if we would like to have some modifiers that actually stack additively with each other? So we're gonna need a new type of modifier for that. I'm going to add a new type here that I'm going to call %add. And just to make things a bit more clear, I'm going to change the old % type to be called %mult, and using Visual Studio's renaming feature, I'm going to automatically rename every usage of the old name to the new one. So once again, we have a new type, and to deal with that, we need to go into the calculate final value method in the character stat script. We'll need a new variable that we're going to call sum %add, and it's going to start at 0. And bear with me here, because this time the calculation is going to get slightly weirder than usual. So whenever we encounter a %add modifier, we won't apply it to the final value yet. We will add it to the variable that we created, and we'll keep iterating through the list and adding all modifiers of the same type, until we reach a modifier of a different type, or until we reach the end of the list. Then, we will grab the sum of all the %add modifiers that we found up until that point, and we'll apply it to the final value, just as we do with the %mult modifiers. For the next bit, let's do something interesting with the stat modifier. Let's add a source variable to our stat modifier class. It's going to be a public read-only object, and we'll call it source. And since this is of the object type, it means we can hold literally any single type that we would like to hold here, ever. You can add a class, it can hold a float or an int or an enum, literally anything. And the reason this is useful is because later on, when we actually start having stuff in our games that add modifiers to the stats, we'll be able to tell exactly where each modifier came from. This can be useful for us as developers, for debugging purposes, but it can also be very useful for the players too. If we wish to share this information, we can tell them exactly what is providing each modifier. And what we can see from our constructors is that the value and the type are required, and the order and source are optional. We have our main constructor here that requires all variables, and then every single constructor requires the value and type, but this one doesn't need either the order or the source, and leaves both of them at their default values. This one needs only the order, and it leaves the source at the default value of null, and this one needs only the source, and it leaves the order at the default value. And now that we have our source variable, we can actually do something useful with our character stat class, so let me give you an example of what that is. Let's say we have this hypothetical item class that gives us two different stat modifiers. If we wanted to equip this item, the way the system works currently, we would have to create our modifiers and store them in variables, and only after that can we add those modifiers to the respective stat. If we wanted to unequip the item, we need to use those same variables and remove the modifiers through that. There's currently no other way to remove a specific modifier. But now that we have the source on our stat modifiers, we can actually implement a way that removes every modifier that was applied by a specific source. So let's implement a method for that. We go over to the character stat class, and right under the previous remove modifier function, I'm going to add another one that I'm going to call remove all modifiers from source. And this is going to take in an object that's going to be our source, and it's going to loop through all of our stat modifiers and remove all of the modifiers that came from the specified source. And there's quite an important detail when it comes to removing items from a list in a loop. The best way to do that, unless your use case demands otherwise, is to traverse the list in reverse, from the last to the first index. That means that I, instead of starting at 0, is going to start at stat modifiers count -1, and it's going to go down until it reaches 0. And now, inside our for loop, we need to check if any modifier comes from the source that we specified, and if it does, we will want to remove it, and we'll set isDirty to true to indicate that something was removed. And besides that, since we want to return a bool, true or false, depending on whether something was removed or not, we need to add a variable for that. We're going to call it didRemove. It's going to start at false. And here, if something was removed, we're going to set it to true. And when we're done removing everything that we need to remove, or not removing anything if we didn't find anything from the specified source, then we will return didRemove. And I want to touch on the reason why we should traverse lists in reverse when removing objects from them. So let's think about this example. Let's say we have a list with 10 objects, and if we remove the first object, what's going to happen? The remaining 9 objects will have to move up one position, and that's because index 0 is now empty, and so the object at index 1 will have to move to 0, the object at index 2 will have to move to 1, and so on and so forth. And as you can imagine, this can be quite inefficient, especially if you have a very big list. However, let's think about the opposite example. What if we want to remove the last object of the list? Well, in this case, if we remove the object at index 9, well then nothing has to be moved, everything else can just stay the same. And that's why we should always try to do the removal in reverse, unless your specific situation demands otherwise. And even in cases like this, where we don't know the position of the objects that we need to remove, and they might very well be in the middle of the list, where shifting the rest of the list around is going to be inevitable, it's still a good idea to do the removal in reverse, because as soon as we need to remove more than one object at a time, doing it from last to first is always going to result in less objects being moved around. And now that we have this method, we can go back over to our hypothetical item class, and first of all, we need to tell these modifiers where they came from. And now with that, we can remove them in a much simpler way by just doing remove all modifiers from source and passing in the item that created them. And we don't even need to store them in variables. We can just do something like this and delete all of the variables if we want. And it results in much simpler code. And since we're talking about removing modifiers, let's do a quick fix to our original remove modifier method, because right now we are setting isDirty to true even if nothing was removed, which means we can avoid unnecessary recalculations of the final stat value by only setting isDirty to true when it's actually needed. And to do that, we are going to check if remove actually returned true, which means that it actually removed something. And now we will set isDirty to true and we will return true. Otherwise, we return false. And we also talked about letting players see the modifiers, but the stat modifiers list is private, and we don't want to change that to public, because we wouldn't want to give permission to anything outside of this class for modifying the list. And even though it's declared as read-only, as counterintuitive as this may sound, the read-only keyword does not prevent changes to the list itself. It only prevents changes to this variable that happens to be pointing to a list. Fortunately, C# has a very convenient data type for this situation, and in order to access it, we need to use the system collections object model namespace, and it's called a read-only collection. In this case, it's going to be a collection of stat modifiers, and I'm just going to call it stat modifiers 2, but with a capital S, because it's public. Oops, public. And in order to initialize this read-only collection, the only thing that we need to do is do equals stat modifiers with lowercase s dot as read-only. And what this does in practice is that the stat modifiers read-only collection is going to have a pointer to the original stat modifiers list, but it's going to prohibit changes to it. However, if we do make changes in the underlying list, in the original stat modifiers list, then the read-only version will reflect those changes too. And the reason this is also declared with the keyword read-only, even though it's already a read-only collection, is the same reason with the other list. We don't want to be able to change what this variable is pointing to after we set it initially. And since we're on the topic of small fixes, there's two more changes that I'd like to make before we finish this video. The first one is going to be in regards to the base value. So because we left this at public, if this value gets changed, it will not trigger a recalculation of the final value, although it should, because the final value must take into account the base value. So let's add some code to fix that. We'll need a private float variable that's going to be called last base value, and it's going to have a starting value of float.minValue. And here in the value property we are going to trigger a recalculation if we have this marked as dirty, or if the current base value is different than the last known base value. And if it is, we will also assign our last known base value to our current base value. And the other change is in the statMod type enum. Let's override the default indexes, like so. And the reason for doing this is pretty simple. If somebody wants to add a custom order value for some of their modifiers, with the old indexes of 0, 1 and 2, it would get pretty awkward to do. Like this, it allows much more flexibility. And as an example, let's think about if we wanted to add a special type of flat modifier to sit between %add and %mult modifiers. In this system, we just need to assign an order value between 201 and 299 to sit between both of these values, while in the old system we would have to change all of the orders for the %add modifiers and the %mult modifiers too. And if you're familiar with Unity's Sprite renderer component, more specifically its order in layer property, or the shader render queue or material render queue properties, then the intent of this change is pretty similar to those. So I hope you have enjoyed this episode. As always, I'll be reading and replying to every comment, and see you next time.